We are all living through the AI revolution, right? But behind all the incredible things we're seeing, there's a massive, growing problem that most of us never even think about. It's not about software or code, it's about raw, physical power. Today, we're going to break down AI's shocking appetite for energy and the really unexpected and kind of controversial solution the tech world is now turning to. Okay, let's get into it. So just to get a sense of the scale here, let's start with something you probably do multiple times a day. You know that ChatGPT query you just ran? Well, on average, it used nearly 10 times more electricity than a simple Google search. 10 times. That's the difference between, say, flipping on a light bulb and firing up a microwave. Now, just imagine that multiplied by billions of queries. You start to see how this thing gets big fast.
But honestly, our search queries, that's just the tip of the iceberg. The real energy monster is training these gigantic models in the first place. It's estimated that training GPT-4 alone ate up over 50 gigawatt hours of electricity. To put that into perspective, that is more power than the entire country of Denmark uses in a single day. All of that just to teach one model. It's just a staggering amount of energy.
And look, this isn't just about a few popular models coming out of Silicon Valley. What we're really witnessing is a fundamental shift in how the internet works. And it's creating this insatiable thirst for energy across the entire industry. And the projections for the future? They are mind-blowing. Goldman Sachs is predicting that power demand from data centers, driven almost completely by AI, is going to surge by 175% by 2030. Think about that. That's like adding the entire energy footprint of a country the size of Brazil to our planet in just a handful of years. This isn't slow and steady growth. It's an absolute explosion of demand.
So why is AI so different? Why can't we just run it like we've run the internet for decades? Well, it really comes down to three things. First, power density. A single AI server rack can pull over 100 kilowatts. That's more than 10 times a regular one. Second, variability. AI workloads are bursty. Think of it this way. The old internet is like a steady hum of electricity. AI is more like a series of lightning strikes, these massive, sudden swings in power that our old-school grids were just never designed to handle. And third, concentration. These AI data centers are all clustered together, putting this incredible strain on just a few local power grids.
And this map right here, this really visualizes that concentration problem perfectly. You can see how just a handful of states, looking at you, Virginia and Texas, are shouldering most of this demand. So this isn't really a national problem that's spread out. It's more like a series of intense regional crises just waiting to happen. And that leads us right to the core of the issue, the electrical grid that we all rely on, which was an absolute marvel of 20th century engineering, by the way, was designed for a predictable world, a world of factories and suburbs that grew slowly. It was never, ever built to handle the explosive, unpredictable, and concentrated power needs of 21st century artificial intelligence. So this really is the multi-trillion-dollar question facing basically every major tech company and government right now. Sure, renewables like solar and wind are a huge part of the answer, but they're intermittent, right? The sun goes down, the wind stops blowing. They can't provide that constant 24/7 always-on power that a data center, which literally never sleeps, absolutely requires. So what can? Well, the answer that big tech is now betting billions and billions of dollars on might actually surprise you. It's not some new kind of solar panel or a bigger wind turbine. It's one of the most powerful and, let's be honest, controversial technologies on the planet: nuclear power. And this has sparked one of the most unlikely but powerful new alliances you could imagine. The super fast-moving world of AI is now partnering up with the traditionally, slow and steady nuclear energy industry to solve its massive power problem. And this isn't just some theory or an idea for the future. It's already happening. Take a look at this. This is Amazon's Cumulus data center campus, built literally right next door to the Susquehanna nuclear plant in Pennsylvania. They just plug directly into the source. They get all the clean, reliable power they need without ever having to touch the strained public grid. And it's not just about hooking up to the old plants either. The really big players are investing in the next generation of nuclear. Google just signed a huge deal with a company called Kairos Power to build and deploy an entire fleet of advanced reactors specifically to power their data centers. Amazon is making similar moves. This isn't just some temporary fix. This is a strategic, long-term bet on a nuclear-powered future for AI. Okay, so what is this new kind of nuclear they're all pouring money into? Forget the giant cooling towers you're probably picturing. The key innovation here is a technology called the Small Modular Reactor, or SMR for short. To put it simply, SMRs are compact, advanced nuclear reactors. But the part that changes everything is right there in the name, modular. Instead of being built from scratch on site, which can take a decade, the main parts can be mass-produced in a factory and then shipped out and assembled wherever they're needed. It's a total game changer. This slide really puts the small modular reactor into perspective. I mean, look at this. On the right, you have a traditional sprawling nuclear plant that can take up over a square mile of land. On the left, an SMR. It's just a tiny fraction of the size, which makes it absolutely perfect for building right next to the data centers it's going to be powering. When you just look at the benefits, you can see exactly why tech companies think SMRs are the perfect solution. They provide that constant 24/7 power that renewables just can't guarantee. Their tiny footprint means they can be built right on site. They're scalable, so as your AI needs more power, you can just add another module. And maybe most importantly, they offer complete independence from the grid, creating a private, secure, and incredibly reliable source of power. This image is just fantastic because it shows that whole modular concept in action. That's an entire reactor module being shipped on a truck. This factory-built approach promises to make nuclear power cheaper, faster to deploy, and more standardized, three things it has really never been before. So, all of this brings us to the brink of a brand new technological era. You could call it the AI atom future, where the digital brain of AI is powered directly by the energy of the atom. It's a future with almost unimaginable promise, but it's also one that comes with some very serious generation-defining challenges. We have to be clear-eyed about the road ahead. The benefits are incredibly powerful, constant, compact, scalable power, but the challenges are immense. These new reactors, as promising as they are, still take years to build and are really expensive for the first few. We'd also need to build out entirely new supply chains for the fuel. And of course, there's the big one. We have to confront the multi-generational question of what to do with spent nuclear fuel. This is not going to be an easy path. So here we are at a crossroads. The insatiable energy demands of AI are forcing a technological solution that, until just recently, was considered pretty much off the table for a lot of people. The question we're left with is a big one. Is this AI nuclear alliance the perfect symbiotic solution that our energy future needs? Or are we just trading one massive challenge for another, potentially even more complicated one? The answer to that is going to define the next decade of technology, and probably a whole lot more.
Thanks for watching. Don't forget to like, subscribe, and share. It really helps the channel grow. See you in the next video.